Here's integrated 3. It's problem 3-52. It wants me to graph and completely describe this function, and you may not recognize it, but there's a yellow sign on the wall in the classroom, and it's a reciprocal function. Sometimes it's called a rational function or a hyperbola. The parent function is 1 over x. The locator point is at the origin, so we're going to look at the graphing form. So this 4, this is our stretch factor, x minus h. So h right here is going to be -5. K is going to be 7. So in order to graph this, I'm going to go left by 5. So I'm just going to look at a graph, and I'm going to go 1, 2, 3, 4, 5. And I'll make a dotted line, or a dashed line here. This is just an aid in graphing. This is actually going to be where the asymptotes are. So that's at -5 because it's shifted left by 5, and it's going to be up by 7. 2, 3, 4, 5, 6, 7. So these dotted lines, they're going to help me guide my graph, and they're also the asymptotes. So I know the parent function is, it's just going to kind of go, it goes like this and like this, but there's a stretch factor, so I'm going to have to put some points in. So I'm going to try to just plug some points in that I think might possibly be nice. I feel like a 3 would be nice to put in here. And why would I say such a thing? I think the 3 would be nice because that would go 1, and then 3 plus 5 is 8. And then that would be like 4 over 8. So I'm just doing fraction math. That's 4 over 8. You know, like 4 times 1 is 4. Anyway, that's 4. That's a half plus 7. That's 7.5. So that just gives me a little point. So 3 comma 7.5. So I think the graph is going to go out like this. I should make my dotted line. It's going to just go off like that. And it's going to go up here. So maybe I need to pick something a little closer. How about, how about -3? Because I'm going to try -3. So -3 plus 5 gives me 2. And then that's 4 times a half. 4 times a half, that's 2, plus 7, that's 9. So -3 is going to give me 9. 2, 3. 1, 2, 3, 4, 5, 6. So that's kind of helping me know how my graph's going to go. I think I'm going to actually just let that be enough, because this is going to be a pretty long video. So just get some points that helps you see how the graph is going to go. It's going to go like that. And then it's going to have a kind of a symmetry on the other side. So let's see. It's going to be one here. And yes, I'm kind of faking it a little bit, but I'm just, because we gotta get the graph in there. We've got the general shape of the graph now, though. Okay, so the only reason I plotted any points is because of that 4. But basically, we know the graph has this general shape. So now we're supposed to completely describe it. So on our wall in our classroom, there is a sign that says how to completely describe graphs. So shape, I'm going to say it's a hyperbola. Or I could say it's a reciprocal function or something like that. Line of symmetry, well, it's not really a line of symmetry. So your answer book doesn't say, like, sometimes it's just like not really applicable to the graph. Like opening up and down, that would be applicable to a parabola, but I'm just not going to really address that with it when I've got this reciprocal function here. Asymptotes, yes, we've got asymptotes. So I have an asymptote at y equals 7 and x equals, was it negative 5? 1, 2, 3, 4, 5. Negative 5. I could go start talking about how it's decreasing and increasing, but I think I'm not gonna really address that one for this graph. The x and y intercepts I do need to talk about. I see there's one here and there's one here, and I know that I can find them so I did some work for the intercepts. So I know I can find a y-intercept when I let x equals 0. So remember the original had x plus 5 down here, so I put in a 0. And then I just did the math, like 4 times 1/5 is 4/5, plus 7, that's 7 and 4/5. And then I just over here did some scratch work. That's 7 right there and 4/5, and I did some fraction math. I got that the intercept is at 7 and 4/5, or you could say it's at 7.8. So I'll just say, what was that, the x-intercept? So 7.8 comma 0. There's just one x-intercept. Or sorry, x-intercept. And that looks about right, because, wait. Sorry, it was a y-intercept. There's a y-intercept. Sorry, it's a y-intercept. There we go. And then the x-intercept is when we let y equal 0. So the x-intercept happens when we let y equal 0. So I plugged in 0 for y, and then I just did some fraction math. Well, I did some algebra. So I subtracted 7 from both sides, and then I divided both sides by 4, and then I saw that I had a fraction equal to another fraction, and I know that if I have a fraction equal to another fraction, that the cross products have to also be equal. So I went negative 7 times x plus 5 is equal to 4 times 1. And I did that over here, and then I divided both sides by negative 7, and then I added 5 to, subtracted 5 from both sides. And then this is negative 4 sevenths minus 5, which I think I did that over here. And I got 5 and 4 sevenths, or 5.57. So I'm going to say, so I did my y-intercepts wrong because I was talking about x-intercepts. It's going to go like that. That's the y-intercept. Right, x-intercepts, x goes first, and that was 5.57. Okay, so I've got those. I got the y-intercept, I got the x-intercept. Domain and range. The domain is pretty much all real numbers except for negative 5. And the range is, I think, all real numbers except for positive 7. And then minimum max, I'm not going to talk about that. And continuous, it's continuous. And is it a function? Yes. Sorry, I've run myself right out of time. And let's look and see what the graph looks like. So, I mean, I already graphed the graph by hand, but then I went on my Desmos app and I graphed it, and I can actually see the intercepts and everything. So that's another option for you guys, and I hope that helps.